These are your notes for March 24th, 2020. Before we get started, I would like for you to just make 2 corrections on your notes from yesterday. For example, number 7, I wrote the answer with a W cubed in it. That 3 was actually the index of that cube root right behind it. So the power of 3 should not be on the W. You can just cross that off. And then for number 8, your final answer should have been a subtraction, not an addition of 2 logs. So if you could make those corrections so that you have it whenever you refer back to them if need be. Today we're going to talk about solving logarithmic equations using our properties of logs. So with logarithms, just like with exponential equations, whenever you go to solve them, you have to make sure that you have a single log on each side. Just like with our exponential equations, we had to make sure we had a single base on each side. So for example, when I had an exponential equation, if I had something like 2 to the x times 2 to the 3 equals 2 to the 5th, I'm not just going to cross these bases off because I have more than one base on this side, and this side needs condensed. So I would have to condense this down to a single base first. 2 to the x plus 3 equals 2 to the 5. And then I would be able to cross my logs off, or sorry, cross my bases off and set my exponents equal to each other. So it's very similar with your logs. You don't want to solve until you have a single log on one side and a number on the other, or a single log on each side. So we have 5 examples that we're going to go through today. So for this first example, you see you have more than one log on this side and you have a number on this side. So this side needs to be condensed. So using our properties of logs, since these logs are being added, I'm going to multiply the things that I'm taking the log of. So this is going to turn into log of 8x equals 3. Okay, and then remember, if you don't see the base on your log, it's a base 10. It's understood to be a 10. It's just one of those things that you don't see, but you kind of know what the number is supposed to be. If you need to write it in there so that it makes it easier when you go into your exponential form, then go ahead and do that. Okay, so now this is my case 1 of my logs where I have a log on one side and a number on the other. So this I'm going to have to go into exponential form in order to solve it. So I'm going to do 10 to the 3rd power equals 8x. And then I just go ahead and solve that. 10 to the 3rd is going to give me 1,000. If you divide both sides by 8, then x equals 125. And then, of course, you always want to be in the habit of checking for extraneous solutions. So the only place up here where I have a variable is right here. And obviously, if I put a 125 there, that stays positive. So that works. Here's another example. Okay, so now this one, I have logs on both sides, and then I have this subtraction right here. So I need to condense this left side down. So log base 5 of 9 minus log base 5 of negative 3x. So I want to condense this down. A subtraction is going to turn into a division. So the left side turns into log base 5 of 9 over negative 3x equals log base 5 of 12. So now that you have it condensed down to a single log on each side, we can cancel our logs off and solve the equation. 9 over negative 3x equals 12. And then I always think about these like proportions. I would put my 12 over 1 and then cross multiply. So if you do 9 times 1, you're going to get 9. And then negative 3 times 12, negative 3x is going to give us negative 36x. Or you can think about it multiplying both sides by negative 3x. Either way, you get the same answer. Divide both sides by negative 36. So x equals 1/4, negative 1/4. Okay, and then go back to the beginning and make sure that you're going to be positive. Okay, 9's always going to be 9, so we're good there. If I put a negative 1/4 right here, that's going to turn this positive, so that's good. And then this 12 isn't going to change. So no extraneous solutions here. This is our answer. Our next example, let's see, I have logs on one side and numbers on the other. I'm going to have to condense the left side down. I'm adding the logs, which means I'm multiplying the things I'm taking the log of. So this is log base 5 of 5x squared times 9 equals 3. Of course, we can simplify that to log base 5 of 45x squared equals 3. Now we're going to go into exponential form because I have a log on one side and I have a number on the other. So 5 to the third power equals 45x squared. So my left side is going to be 125. Divide both sides by 45. If we simplify that, that's going to give me 25 over 9. So this is quadratic. Excuse me. You want to solve by taking the square root of both sides. You take the square root of a fraction, you take the square root of the numerator and the square root of the denominator. So x equals plus or minus 5/3. And you want to go back up here and make sure that plus or minus 5/3 is going to work. So if I plug in here, the positive 5/3 is going to make this positive. The negative 5/3 is going to get squared and go positive, so it's also going to stay positive. So both of those answers work. Okay. And then this one, again, I have more than one log on one side, so I want to go ahead and condense that down. So we're adding our logs, so that means we're actually multiplying these two things together. So log base 9 of the quantity 4 minus 2x squared times 8 equals log base 9 of 16. So we want to simplify this, distribute this 8. So we end up with log base 9 32 minus 16x squared. So we have a single log on each side. Both are the same base. Cancel the logs off and solve the equation. Okay, and then we, again, are going to take the square root. So x is plus or minus 1. Go back and make sure they both work. The only place I have a variable is right here. We're going to square it, so it's going to go positive, so both of those answers are going to work. And then our last example, very similar to the one we just did, except this one only has the logs on one side. So we're going to condense the left side down by multiplying. Let's simplify the left side first by distributing your 4. So we end up with log base 3 of the quantity 36 minus 8x squared equals 3. Okay, so now it's all condensed. We have a log on one side, a number on the other. So for this one, we have to go into exponential form. So 3 to the third equals 36 minus 8x squared. And 3 to the third is going to give us 27. Subtract your 36 from both sides. And we're going to divide both sides by 8, negative 8. Okay, so this gives us positive 9 over positive 8 equals x squared. Okay, so now we have to take the square root of both sides. Taking the square root of a fraction, we take the square root of the numerator, then the square root of the denominator. Oops. So the square root of 9 is 3, and the square root of 8, remember 8 is 4 times 2. So this turns into, if it's a square root of 8, it's a square root of 4 times 2, which is 2 square roots of 2. And we have plus or minus. Okay, so anytime this happens and you're left with a radical in the denominator, you want to make sure you rationalize your denominator. You have to multiply the top and bottom here by the square root of 2. You're not allowed to leave a square root in the bottom. Okay, so our numerator, plus or minus 3 square roots of 2. And our denominator, this is just 2 times 2, because when you multiply these guys together, you just get a 2. And 2 times 2 is 4. Go back and make sure these are going to work. And again, the only place we are putting a variable or substituting for a variable is right here, and it's going to go positive. So that's going to be good, but I would punch out in your calculator and make sure it's going to work. 9 minus. Yep, looks good. Okay. If you have any questions, let me know. Have a nice day.